Okay, 5-1. Using properties of exponents. There are 2, 4, 6, 7 properties we need to memorize. Product of powers, okay? Now, if you notice, on all of these, this says a to the m times a to the n. This a here, whatever your power is being applied to is called your base, okay? So, in this case, a is my base. If my base, okay, this is my base. If my bases are not the same, then I can't do anything. Okay? I need my bases to be the same to apply these rules. So if I have a to the m power times a to the n power, what I get is a to the m plus n. When you have multiplication, you are adding powers. Do not get confused by that. Do not multiply the powers, add the powers. Okay? So if I have 5 cubed times 5 to the negative 1, I get 5 to the 3 plus negative 1, which gives me 5 squared, and I'm going to get an answer because there are numbers in there. So I'm going to take it as far out as I can. I'm going to evaluate it when it has numbers, okay? When I get to like letters and things, I'm simplifying. I can't give you an answer. There's not a number in there to give you an answer with, okay? When I have a power of a power, which means when I have a power raised to another power, that is when I multiply my powers together. So here I have a to the m raised to the n. I'm going to get a to the m times n. 3 cubed squared. I'm going to get 3 to the 6th. I multiply those numbers together. 3 to the 6th is 729. Power of a product. Okay, power of a product. That means that my numbers are being multiplied together and they are being raised to the same power. If I need to solve that, I can separate those apart. Okay? Because sometimes they're going to give me things where I have numbers and letters together, so it will be easier to separate them and then apply the rules to both individually. So I have a to the m and b to the m. 2 times 3 to the 4th. I have 2 to the 4th times 3 to the 4th. You get 1,296. You cannot have negative exponents, period. If there are negative exponents, you have to turn it into a fraction. If it's already in a fraction, you bring it out of the fraction. You cannot have negative exponents. So if I have a to the negative m, I'm going to put it under 1 so that I can solve. Okay? 1 over a to the m. 7 to the negative 2. 1 over 7 squared equals 1 over 49. If it said something like 1 over 6 to the negative 2, I would change it to say 6 squared, which is 36. You can change them back and forth, okay? If it's in the bottom and it's negative, you're going to flip it up top so that it becomes positive. If it's up top, you're going to flip it below so that it becomes positive. I need positive exponents, okay? 0 exponents is the easiest. Anything to the 0 power is 1, unless this constant, this base, is 0 itself. That's the only time it doesn't work. So negative 12 to the 0 power is 1. 1 over 27 to the 0 power is 1. Anything to the 0 power is 1. B to the 0 power is 1. Okay? Even if I have a letter to the 0 power, I still get 1. Okay? Quotient of powers. When I have division happening and my bases are the same, a and a, my bases are the same. A to the m, a to the n. I am going to subtract. Division means subtraction. Multiplication means addition. Okay, I'm going to subtract my powers. So a to the m minus n. A cannot equal 0. Why can a not equal 0?
Because
because then we cancel out and then do 1.
Well, no. Look, you have a fraction. What do you know about fractions and 0?
it's supposed to be anything 0.
What, Kaylee? Yeah, I can't have a 0 in my denominator on a fraction, right? It's an undefined term. Good, Kaylee. So that means that's why this can't be 0, because my base can't be 0. Okay, my bottom can't be 0. So if I have 6 to the negative 3 over 6 to the negative 6, that gives me 6 to the negative 3 minus negative 6, which gives me a double negative, which is a positive. So I get 6 cubed, which is 216. This is where people mess up the most, is if it's a double negative, we forget to make it a positive and vice versa, okay? So be careful with your signs because you're subtracting, okay? Power of a quotient. If I have a fraction raised to a power, I can divide each of those individual pieces up and raise them to that power individually. So a to the m over b to the m. Once again, b cannot equal 0 because 0 cannot be in my denominator spot, okay? So 4 over 7 squared gives me 4 squared over 7 squared, which is 16 over 49. If that was reducible, you would reduce it, okay? That brings us to evaluating. When it says evaluate, I want a number answer. Okay, evaluate, you're giving me the full number. So how do I
Please
fix?
excuse this interruption. Chloe Halsey, Eugene Mervin, and Carissa Shaw.
they have a
Please
picture.
come to the
How do
front
I
lobby.
fix negative 4
Chloe Halsey, Eugene
times
Mervin,
2 to the 5th
Carissa Shaw.
squared? What do I need to do first with that?
Power of a product.
Yeah, power of a product. Good. So you want to distribute that power that's on the outside into each product, right? What technically is with this negative 4? What power?
0.
No.
Wait,
1.
1. Anytime there is not a power here, it is 1. Which means something when we come to product of powers, right? Because when we have that, you got to remember that that 1's there because it will be like 6 times 6 squared. Well, that's 6 cubed because it's 2 plus 1 is 3, okay? If I have this, negative 4 to the first squared, that means I do have a power of a product, but I also have a power of a power happening now, right? So what is negative 4 to the first squared? What does that come out to be? Negative 4 to what power?
Cube.
No.
Wait.
Squared. Why squared, Drew?
because you're basically multiplying.
Yes, because when it's a power of a power, I'm multiplying.
Oh.
When it's a product of a
It's like
power,
I
I'm
didn't
adding.
think it was a. I didn't think it was a.
It's like distribution.
Yes, it's like distributing. Good. Okay. Now, what about here? 2 to the 5th is going to come out to what?
2 to the
10.
2 to the 10th. What is negative 4 squared? 16. And what is 2 to the 10th? You might need calculators today.
I did before you. 124.
No, not 100.
1,000.
Okay. Now, I'm going to finish this by doing what? Yeah, so multiply 1,024 by 16, and what is your answer?
Wow, that's a big number.
1,000.
16,384.
16,384. I have now evaluated that. Okay, here I have 11 to the 5th over 11 to the 6th to the negative 1. What are you going to do first?
Oh, wow. Distribute go to negative 1.
You want to distribute the negative 1 first?
Yeah.
Okay, so if we distribute the negative 1 first, we end up getting,
We get a negative on the bottom.
you get what?
A negative on the
Yeah, so I'm going to get this. I'm going to get 11 to the negative 5 over 11 to the negative 6. What do I have to do from there?
You got to flip.
I got to flip both of them because they're both negative. So that means I get 11 to the 6th over 11 to the 5th. Now what happens?
Then you do quotient of power.
Then I do quotient of powers, which means what am I doing with these powers?
Subtract.
Subtracting. So 6 minus 5 is what? So 11 to the first, which gives me what?
11.
Beautiful. Okay. Let me tell you a secret about C. Here's what you're going to do on this one. Okay? Do you see how this says 6 times 10 to the negative 4 and 9 times 10 to the 7? The power is with the 10. Okay? I'm going to reduce these numbers if they're reducible. What is 6 over 9 reduced to?
2 over 3.
2 over 3.
Wait, that's
So I have 2 over 3, okay? And then I have times 10 to the negative 4 times 10 to the 7. What do I do with those?
Track.
Subtract, good. So I'm going to get
I see what you
2 over 3, and then I have 10 to the negative 4 minus 7, right? What's negative 4 minus 7?
mean.
Negative 11. Sorry, I should. So I get 2 times 10 to the negative 11 over 3. What do I have to do now?
Flip that.
Flip the 10, right? So I get 2 over 3 times 10 to the 11th. Now, they said to evaluate, correct? Is that what I said to do? Oh, yeah. Evaluate the expression. Here's the deal. This is fine to leave in this form. What form is this called? When something is 3 times 10 to a power.
Scientific notation.
Yeah, so I can leave it there because that is evaluated because it's in scientific notation, okay? But that's how you have to solve that problem. Does that make sense? So we're taking things just one little step at a time. Okay, scientific notation. The form is constant times 10 to a power, where 1 is less than or equal to my constant, and my constant is less than or equal to 10. Okay? This number cannot be greater than 10. Does that make sense? Okay. A swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in such a swarm? How can I figure that out?
Why do we want to figure that?
Because we want to put it in scientific notation.
You would do 8.5.
Okay, you want to do 8.5?
Yes.
Okay. Because of
Oh,
the
I see, yeah.
85 million. If I'm doing 8.5, what am I multiplying by? 10 to what power?
Wait.
6 or 5?
Look, 85 million, right?
Yeah.
I
Thousand.
need to.
So I moved my decimal 1, 2, 3, 4, 5, 6,
Oh, 7.
7. Okay. Do you guys understand how we got that? 8.5 times 10 to the 7th. Okay. So, locust per square kilometer and covers an area of 1,200 square kilometers. About how many locusts are in such a swarm? So what else do I have to do to this?
Do.
Put that over.
1.2.
Yes, 1.2
times 10 to the
times
third.
10 to the third. Is that what you're saying?
Yes.
Okay, times 10 to the third. Good. I like that. So we have this. In order to figure out how many is in this area, we're multiplying these two things together, right?
Yes.
Now, remember how over here on division, we, reduced those first and then we took care of this? We can do the same thing with this. We can take 8.5 and 1.2 and write it in its own multiplication sequence. And we can take 10 to the 7th and multiply it by 10 to the 3rd because I can combine those things that are in scientific notation that way. What is 8.5 times 1.2?
Oh, and then just multiply all
Yeah, yeah.
together. Okay.
10.2.
Okay, so I get 10.2. And then this is 10 to the 7th times 10 to the 3rd. So what do I get?
10 to the 10th.
10 to the 10th. Beautiful. Now, I have one problem. Because I'm not quite done with this. What's wrong with this right here?
That's technically bigger than 10.
It is technically bigger than 10. So what do I have to do?
You have to move it over one more.
Yes. I have to move it over one more, which does what to this?
Decreases it.
No,
Increase.
increases. So I get 1.02 times 10 to the 11th. And that's my final solution.
Oh.
Okay? Because when I move my decimal over again, I have to add one more power. Because technically I changed this to 1.02 times 10 to the 1st.
Okay.
Okay? Does that make sense? Okay. Last little piece of stuff we're going to simplify. which means I can't get answers, right?
I
Okay.
feel like it's gonna take a long time when we do the homework.
How do I simplify b to the negative 4th times b to the 6th times b to the 7th? What rule is happening?
Powers of products to power.
Products of powers. So I'm going to do what with those exponents?
Add them.
So I have negative 4 plus 6 plus 7. What's negative 4 plus 6?
2.
And what's 2 plus 7?
9.
So I have b to the,
9.
and that's simplified. Okay? What am I doing here when I have r to the negative 2 over s cubed? Okay, these are different, right? So I can't do anything there. So what do I have to do with this?
Is that a 5 or an S?
That's what?
That's the S.
That's an S.
So it's power of a quotient.
Power of, nope. It's not power of a quotient. Here's why. Because these aren't the same base.
Oh, okay.
Okay? Same base for it to be power of a quotient. Well, wait. I get what you're saying. You are correct. It is a power of a quotient because it's a division. I'm thinking it's a power of a power, but
I don't know.
it's power of a quotient. Okay, so what do I do? What does r become up top?
Oh wait, you.
R to the what?
Becomes
R.
negative 5.
Nope.
R
R
to
to
the
6.
6.
6.
Oh, you
Negative
won't-
2 times negative 3 is 6.
And then
What's on bottom?
you S to the negative 9.
Okay, what's wrong now?
You can't have negative.
So what do I do with that?
Flip it.
You only flip the one that's negative.
Yes.
Okay? So it's going to end up saying r to the 6th, s to the 9th. Okay? Only flip the one that's negative. Does that make sense? Now,
Oh.
here, what am I going to start with this 16 and 2?
Reduce it.
Okay, so what's 16 divided by 2?
8.
8. So I have 8 m to the 4th, n to the negative 5th, over n to the negative 5th. What do I have to do? Is there any m things to work with?
No.
So I just get 8m to the 4th. Now, what do you have to do with the n's?
But you have to subtract.
Subtract. So I have n to the negative 5th minus negative 5. What?
Which is 0.
Which is 0. Which means n becomes what number?
1.
Good. So I have 8m to the 4th, right? Boom. Okay. What do I do on D over here?
Power of a power.
Power of a power first, because I have to take care of what's up top first. So if I do that, what's x to the negative 3 squared?
Negative 6.
Negative 6. And what is y cubed squared?
6.
Y to 6.
Good. And then on bottom I have this, right?
Yes.
Now what do I do?
Subtract.
Subtract. So I have x to the negative 6 minus 5, and I have y to the 6 minus 6. Okay. X to the negative 6 minus 5 gives me what?
X to the negative 11.
And y to the 6 minus 6 gives me,
0.
which gives me what number? Okay. What do I have to do now still?
Put on the bottom.
Yep, because it's a negative, so I just get this as my final simplified version. Cool? Okay. What am I going to do here? I can do one of two things first here. Okay? I can subtract my exponents first inside because I have a power of a quotient, right? No? I lied. I have a quotient. Yes, quotient of, right? Quotient of powers. Or I have this on the outside, right? And I have a power of a quotient and I can distribute it to all my pieces first. Either way, I'm going to get the same answer if you do your math correctly. Okay?
Would it be easier to do the quotient of powers?
You want to do quotient of powers first and subtract first?
What would be
It doesn't matter. Whichever way you see it is easier. Okay? You want to subtract first? Okay, so you want to do 4 minus 3 first and negative 2 minus 6, right?
Yes.
And then it's like this, correct? Okay. 4 minus 3 is, and negative 2 minus 6 is negative 8. So you get this. Now what do you want to do?
Multiply.
Okay, so x cubed is cubed, and what is negative 8 and 3 cubed? What is negative 8? negative 24. Is that right? Then from there, what are we gonna do?
You're gonna have to flip. Change. We have to flip the y on the bottom.
Okay, you wanna flip it onto the bottom? Beautiful. So I get x cubed over y to 24th, and everything is simplified. Okay? That is what we're working on in this
I
lesson.
have a question on
Okay, ask me your question.
well, again, so D and E, one only has parentheses on the top and one has parentheses over the whole thing. So, would the whole thing?
So on D, you have to start with parentheses, like order of operations. Okay? On E, this is getting applied into everything. So I can start and simplify first if I want to, or I can distribute this first. It doesn't matter. You're going to come out with the same answer.
Alright.
Okay?